Welcome ICSE Class 10 students. Today, we're going to master arithmetic progressions to solve complex board-level problems. Look at this ladder. Notice how the physical space between every single rung is exactly the same. That rigid consistency is what separates a random list of numbers from a true arithmetic progression. If we map those rungs to a sequence of numbers, say starting at 3 and dropping to 0, then -3, then -6, the drop is an exact identical jump of -3 every single time. In mathematical terms, that starting number is our first term, which we call A. The exact jump between the numbers is the common difference, or D. To find it, you simply subtract the first term from the second. Here, 0 minus 3 gives us a D of -3. Getting that common difference right, especially when tracking negative signs, is the strict foundation required for solving every single problem in this unit. If I asked you to find the 100th number in that sequence, you wouldn't calculate it by hand. Instead, we use the general term formula. This equation states that any term, a sub n, equals the first term plus n minus 1 times the common difference. Let's apply this to an ICSE question. This problem asks for the 15th term of our sequence, 3, 0, -3, -6. We know our first term, a, is 3. Our common difference, d, is -3. And since we are looking for the 15th term, n is 15. Plugging those variables in, we get 3 plus 14 times -3, which calculates out to -39. The general term formula replaces laborious manual counting with a reliable 3-variable substitution exercise. Board exams frequently test your understanding of these variables with a specific trap, asking you to verify if a random large number belongs to a given sequence. Look at question 8. We assume 402 is our nth term in the sequence 8, 13, 18, and 23. The first term is 8. The difference is 5. Tracing the algebra to isolate n, we get 399 divided by 5. That resulting fraction is the entire proof. Because n represents a physical position in a list, like first, second, or third, it must be a positive integer. Receiving a fractional position proves the number does not exist in this sequence. Calculating the aggregate value of a sequence requires two summation formulas. One leverages the common difference, while the second provides a shorter path if you already know the last term, L. Here's a summation problem for the first 20 terms of sequence 4, 7, 10, 13. Pause the video and solve it. Let's check. A is 4, D is 3, N is 20. Plugging these into the formula simplifies smoothly to a sum of 650. Recognizing when a problem hands you the last term so you can use the shorter formula is a crucial tactic. That single observation saves valuable minutes on a timed exam. The arithmetic mean is the exact midpoint between two boundary numbers. In question 9, finding the mean between 3 and 13 is as simple as adding them together and dividing by 2, giving us 8. For word problems asking you to find 3 unknown consecutive terms, you must format your sequence using the variables a minus d, a, and a plus d. Structuring your variables this way ensures the d terms cancel when the 3 terms are summed, providing a direct path to the value of a. Let's test these linear tools on a high-complexity question. Question 10 asks us to find the number of sides of a polygon where the interior angles form an AP, starting at 120 degrees and increasing by 5 degrees. We equate our AP summation formula directly to the standard geometric formula for the interior angles of a polygon, which is 2n minus 4 times 90 degrees. Once we substitute our A of 120 and our D of 5, the geometry aspect is finished. Expanding the brackets and collecting all terms to one side reduces this setup into a clean quadratic equation. N squared minus 25n plus 144 equals 0. Factoring that quadratic provides two potential roots, 9 and 16. In your exams, you should check these results to ensure the resulting interior angles are geometrically possible. Here, the source confirms both as acceptable values for the number of sides. Methodical application of AP logic. ICSE success comes down to identifying your variables carefully, trusting these formulas, and executing the algebra methodically. Review these steps and you'll be ready for the board exam.